our conversation. Good afternoon, Christine Calbrinas and everyone. Let's continue our discussion on good afternoon, all the greeters and everybody. Let's continue our discussion, guys, on GFR test. Last night, I enumerated two important GFR tests. Okay, we have the both letter C. We have the clearance and cystatin. Now, let's continue with the other GFR tests. O guys yung mga may handbook at saka yung walang handbook, you have to write this because these are other GFR tests, okay? So what are these other GFR tests? First, we have the beta trace protein, page 104. You have the beta trace protein, okay? Sandali pala turn off ko yung video, guys, kasi kaninang morning, muntik na ako magsabi kay Ma'am Edith na naman ang cancel dahil meron kami internet pero sobrang tagal makakonect. So thank you, Lord. Ngayong hapon meron na, okay? Alam ko na kung bakit. Vacation na kasi. So mas lalong bumagal yung internet pala pag vacation. Mas maganda pa pala pag may pasok. Okay, may school days. Pag may vacation, everybody kasi is into the internet now. So I have to stop video I will put off my video again, guys Okay, baka bigla ako mag-lag kasi. So, the beta trace protein, page 104. Again, guys, take note of the heading. This is other glomerular filtration rate. It is important in our licensure examination to identify the classification of the test. Is it GFR test? Is it renal blood flow? Is it tubular function? I am sure simula pa nung nag-start tayo ng carbohydrates, naka-classify, guys, ang ating mga tests. Hindi ko basta sinasabi lang na fructosamine, HbA1c, kailangan naka-classify siya. Ano ba yun? Test ba yun o sample? Both. It is also the test and the sample. Okay? So in short, here, we have beta trace protein. This is a low molecular weight glycoprotein. And, ano mo ang kanyang characteristic? Sino ang kanyang kamukha? Freely filtered at the glomerulus, it is a protein completely reabsorbed and catabolized by the proximal convoluted tubule after reabsorption. Question, sino ang kamukha nito, guys, na GFR analyte, which is also reabsorbed completely and also catabolized after reabsorption, is also catabolized by the proximal convoluted tubule. So anong maiisip mo dito? Ma'am, ibig sabihin, this is not present in the urine specimen? Of course, because this is completely reabsorbed. So it's like similar property with the cystatin. Okay, what else? This is, of course, present in plasma because we're using serum as the sample. Okay, very good, Antonio Oriza. Okay, but tandaan natin, children, this is also found in CSF. Take note. In fact, my goodness gracious, great balls of fire. B is for brain again. Diba? B is for brain. Bakit? Because the plasma concentration of BTP actually originates from the brain. So anong ibig sabihin nitong question na to? What is that renal marker that is actually secreted in the brain? My God. Nako, pag mo kakalimutan niya, that is beta trace protein. What else? And there are two formulas or there are two formulae which is actually written already in your handbook. Nasa handbook na yan, guys. Okay? What else? And what is the significance of BTP? Remember, the plasma concentration of BTP originates from the brain. My goodness gracious. What is the significance of this test? Ay, syempre, increased plasma BTP is renal disease. Ma, bakit mo pa ina-emphasize yung plasma paulit-ulit? Kasi this is never measured in the urine sample again. Because this is just like cystatin, which is completely reabsorbed, never excreted. Okay? And nakalagay dito, it is increased in renal disease because of reduced filtration in the presence of constant production. Because of reduced filtration in the presence of constant production. Okay? Huwag kakalimutan yan. That is so important. What else? How about Beta-2 microglobulin. Minention ko na to sa iyo last night, pero uulitin natin para matandaan mo. Ma'am, di ba may nabanggit ka na protein na renal marker? There is only one plasma protein I mentioned last night. Only one. Hindi, actually dalawa yan, pero cystatin yung isa, which is also a protein, no? Protein din yun. Pangalawa ito, si beta-2 microglobulin. Bakit ulit mo, ma'am? Ay, syempre, para matandaan mo ang classification niya. It is not just a protein, it is a renal marker. What type of renal marker? Because there are 3 types of renal marker. GFR, RBF, or TF. What is the answer? GFR. Remember, this is part of the other GFR test. It is found on the surface of most nucleated cells. Nasabi ko rin sa page 95. And what else? Freely filtered, then reabsorbed, and what? Completely metabolized by the proximal tubule. So ano na naman ang maiisip mo? Ma'am, hindi po siya normally na may measure sa urine. Tama. Bakit ba walang underline yung completely reabsorbed? Dapat guys, meron ha. This is reabsorbed, completely reabsorbed, and completely metabolized by the proximal tubule. Naku, kaya nakalagay na naman dyan, elevated plasma levels are result of impaired clearance. And this is actually increased in inflammatory diseases such as rheumatoid arthritis and lupus erythematosus. What else? Beta-2 microglobulin is a common cause of dialysis-associated amyloidosis. Baka meron ditong nakaupo na part na graduate ng old curriculum. Alam ko nang sasabihin mo, Ma'am, I am an alumnus or alumna of PERC. Matagal na po ako nag-enroll sa PERC, ma'am, 1 year ago, 2 years ago. Ma'am, bakit wala ka naman binanggit, Dean Rodriguez, na beta-2 microglobulin doon? Hindi ka din po nagbanggit ng beta-trace protein. O, di ba natatandaan mo sinabi ko sa iyo, those who belong in the old curriculum, mag-take ka na ng board exam before. Ma'am, I was so busy. Okay, walang problema. Sabi ko kasi walang problema, di ba? Basta umattend ka ulit sa review kasi you have to what? To know what are the new entries in the discussion. So alam ko na sasabihin mo, Ma'am, hindi mo diniscussion dati under GFR test. Kaya nga sabi ko sa iyo, yung curriculum na tayo ngayon eh. So these are the additionals. Take note of that. Ano nakalagay dito? Common cause of dialysis-associated amyloidosis. O alam ko na itatanong mo, Ma'am, sabi mo this is completely reabsorbed, completely catabolized by the PCT after reabsorption. Ay bakit meron siya sa urine? Kasi kamukha na naman siya ni cystatin. The presence of B2M or BTP or cystatin in urine, that is abnormal. Why? Because these 3 proteins are renal markers which are never measured normally in healthy urine. The cystatin, the BTP, the B2M. Ano yung B2M? Beta-2 microglobulin. They are not normally present in the urine sample. Tandaan natin yan, children, because they are completely reabsorbed. They are in healthy urine, the concentration should be what? 0 for these 3 proteins. Eh bakit germ positive? Ay syempre pag merong damage to the proximal convoluted tubule. That is the tubule that is responsible for complete reabsorption. E di ba nagka-damage sa tubule na, edi lalabas siya sa urine. Take note. Next, then, mama na po sample natin madalas, eh syempre plasma. Kasi nga, we don't use urine kasi ina-expect mo siya 0 doon eh. Unless there is damage to the proximal convoluted tubule. So, increased plasma B2M is renal failure, multiple myeloma, also inflammatory diseases such as rheumatoid arthritis, SLE, and of course, there is also what? Severe immune damage. What is that? Those persons with HIV. Okay? Ang sinasabi ko sa increase, plasma B2M yan. What else, guys? And, well, we use immunoassay, and that is the usual concentration of beta-2 microglobulin. Ma'am, bakit ang baba-baba niyo sa blood? Eh, kasi completely metabolized. Sinisira din siya ng convoluted tubule. Bakit? It has no function in the body. Those without function in the body should be destroyed by whatever organ. Oh, remember, why is it that cystatin, BTP, and B2M, they are, after complete reabsorption by the kidneys, they are destroyed also by the kidneys. Because they don't have function inside the body. Tandaan natin ang sabi ni kidneys, lahat ng may function out. So, meron kang na-discover ngayon. Kidneys are not only excretory organs, they also have catabolic properties. Oh my God. Naku, si Ryan Moraleta, tandaan mo yung sinabi ko niyan. May catabolic. Pag yan lumabas sa board exam, hindi ba tandaan ng mga students? Nako, wala na. Panalo na. That is not all the time. Hindi lagi nababanggit siya. Guys, ha? Mom, are you saying, Mom, si kidneys, pero din catabolic nature naman. Yan tatlong proteins na yan. Okay? Kaya mababala ang concentration sa blood. O ano pa tatandaan mo? Aba, meron ng RFI. In fairness, hindi lang RFID, ha? May RFI na. Ma, bakit lagi mong inuulit yung mga acronym? Nako guys, noong pre-pandemic, syempre we have a new set of examiners children, ha? Hindi natin alam kung ano pa yung lalabas sa board exam, pero tandaan natin, pre-pandemic, nako may mga acronym sa board exam. May mga umiiyak dyan, nakalimutan nila yung acronym. O ano yung RFI? Renal failure index. What is that? This is used for differential diagnosis of acute renal failure in the presence of oliguria. There is a formula. Huwag mong kalimutan yan. In fairness, sodium ang nasa computation. Urine sodium times serum creatinine over urine creatinine, that is the RFI. Baka ipa-compute sa'yo yan. Ang creatinine clearance po ay walang urine sodium, ha? Careful, careful. Pag nakita mo yung tatlong yan, ako, nasa mindset mo, RF major kidney function test. What is the second major kidney function test? Renal blood flow. Bago tayo umalis ng tests for GFR, there are routine tests and there are other tests. What are the routine tests under GFR? Syempre clearance. Ano pangalawa? Cystatin. Okay? Next. And what are the other tests? Well, we have the BTP, the B2M, at saka yung RFI. Okay? Yan, tanong din yan ng bayan sa akin. Madam, ikaw ba yung first ever Filipino who made a study on beta-2 microglobulin in the Philippines as a renal marker? With all humility, children, ako nga yun. Because actually, the beta-2 microglobulin is my thesis when I'm completing my Master of Science in Medical Technology, and the same was also presented in other countries as far as the USA and the Europe. Okay, so yan ang madalas nilang itanong sa akin. Ma'am, ikaw po ba yung author talaga ng cystatin? Yes. Ma'am, ikaw din po ba yung author ng B2M? Yes, but in cystatin, okay, it is a team actually, and inulit ko ang beta-2 microglobulin test also as a marker, renal marker, okay. Inulit ko yon after after my master's thesis is now paired with cystatin. Kaya masasabi ko that beta-2 microglobulin is really a good marker for glomerular filtration rate, but cystatin is a higher marker. Okay? What are the tests for renal blood flow? Ayan, iniisa-isa ko sa iyo, ha. Para relax ka sa board exam. Anong ilalagay mo sa heart mo? Ay, wag mo expect which of the following is a kidney function test. Ganon ang question sa board exam? Of course not. It requires what? Classification. Sa title pa lang, renal blood. So ano lang sample mo dito? Blood. Anong sample mo sa GFR? Pwedeng urine, pwedeng blood sample. However, take note of all the GFR tests. What is the only GFR test? What is the only GFR test that requires urine specimen? What is the only GFR test that requires urine specimen? Requirement, requirement, urine. Nako, ang tagal sumagot. 5, 4, 3, 2, 1. Richmond Luis Estolas. Excellent. Anong answer niya? And Katrina Carlos. What is that? And Victoria Ebony. Clearance. Remember, under GFR, the only test that requires blood and urine is the clearance test. Huwag mong kalilimutan yan. Si Renal Failure Index, si RFI, yun ay mga adjunct test lang yon si RFI. It also requires urine. Remember, urine sodium, urine creatinine yung children, ha? Kaya lang yung mga routine talaga, si clearance. Okay? The test for RBF, syempre blood lang ang sample mo dito. First is urea nitrogen. This is the major end product of protein catabolism. Of course, this is the most abundant NPN. And take note that this is 45% of the total NPN in plasma and 80% of the nitrogen excreted. What else? This is produced in the liver, but renal marker. Again, this is produced in the liver, but it is a kidney test, not a liver test. Remember that. Next. So, blood urea nitrogen concentration. Is it sign of kidney disease? Syempre hindi. In-explain ko na yan kagabi, paulit-ulit, di ba? Remember, the main function of the kidneys is the formation of urine. Because formation of urine is the only expression of the elimination of wastes. Remember that. That is the only expression of the elimination of waste. Tandaan natin yan. At sabi natin, bakit tinawag si BUN, si creatinine, at si uric acid na kidney function test? Because the three measures, the three analytes measure the main function of the kidney, and that is to eliminate wastes. So, what happened if they are not eliminated? That is kidney dysfunction. Oo nga. Kaya nakalagay dito, low BUN is not kidney disease. It is severe hepatic disease. Because if the kidneys are not functioning well, then BUN should be what? Increased. Remember that. So therefore, it is the first metabolite to increase in kidney diseases. Huwag kakalimutan yan. The first metabolite to increase in kidney diseases. And it is easily removed by dialysis. Reference value is around 7 to 20 milligram per deciliter. How will you convert it to millimole per liter? Times 0.357. Times 0.357. Huwag kalimutan yan. Mom, do we need to memorize the milligram per deciliter? Yes. Do we need to memorize the millimole per liter? No. Ang dapat mong i-memorize yung conversion factor. Mom, sa board exam ba until last March, there are questions on interpretation of results. Naku, ang dami. No? May numbers, may sentence. So anong dapat natin tandaan sa reference value? Yung conventional. And memorize the conversion factor. You don't need to memorize the millimole per liter. Okay, as long as you know the conversion factor. So how do we measure urea? Well, there is direct method. This is a chemical method. This is an obsolete method. This is a colorimetric method. Hindi na natin to we are not using this anymore. And why are we discussing this, Mom? Kasi syempre, kasama sa multiple choices yan. Pag hindi mo alam si acetylmonoxide na obsolete, mag-a-answer mo, di ba? So this is direct method, this is chemical method, this is colorimetric method, but obsolete method. Currently, we're using urease. That is the routine method. Or the combination of urease and GLDH. What is GLDH? Glutamate dehydrogenase. Do not forget that. The glutamate dehydrogenase. What else? And take note that the ammonia and carbon dioxide produced in the reaction in this enzymatic method, either urease or combination of urease and GLDH, always remember that it says here, are measured by various methods to calculate the concentration of urea in the original sample. Nasa book mo na yan. So ang nakalagay dito, guys, anong ibig sabihin itong statement na to? Huwag mong kakalimutan that the product that is measured in the indirect method is ammonia. And whatever is the concentration of ammonia, that is same concentration of urea. Reference method, which is not routinely used, is IDMS. That is the reference method. Take note, not routinely used. That is IDMS. Ma'am, bakit hindi siya routinely used? expensive method, best for research purposes. So what is the current routine method? Enzymatic. Urease or combination of urease and GLDH. How about creatinine? The second RBF test. This is end product of muscle metabolism. Naku, ilang beses ko na sinabi yan. Production is constant for 24 hours. That's why, yeah, though the request is creatinine clearance, we don't inject creatinine because that is a waste product. Okay, and this is endogenous and produced produce constant concentration in 24 hours. Unlike urea, this is not easily removed by dialysis. Naku, tandaan natin yung people. Not easily removed by dialysis, and this is considered an index of renal function. This is an index, do not forget, of renal function. Pagkalimutan yan. That's why this is the most commonly used RBF test. Reference level, 0.5 to 1.0 milligram per deciliter. What is the conversion factor to make it micromole per liter times 88.4? That is the conversion factor times 88.4. And we all know that BUN is higher than serum creatinine. Eh, alam natin yan. Tingnan mo yung concentration kanina ng BUN, 7 to 20 milligram. Eh, ito, 0.5 to 1.0 milligram. So what is the ratio and proportion of the two? 10 is to 1 to 20 is to 1. Okay, 10 is to 1. Do not forget, to 20 is to 1. What else? How about methodologies? Okay, for the methodologies, the chemical method is known as Jaffe method. Pakitingnan ang libro ninyo, nakalagay dyan, Jaffe method. Ops, what is the Jaffe reagent? Jaffe reagent is combination of picric acid and sodium hydroxide. Take note of that. The combination of picric acid and sodium hydroxide, you put them together, alkaline picrate. That is the alkaline picrate, guys. Okay, do not forget. And remember, Jaffe reagent is an unstable reagent. In fact, it should be freshly prepared. It is an unstable reagent and should be freshly prepared. Take note. Otherwise, if you allow that to stand more than 1 hour without using it, that will be converted to another product. Next, Jaffe method is a non-specific method. Tandaan natin yan, guys. Isa pa yan, ha? It is a non-specific method. Take note, which means you can measure other analytes, not only creatinine, because it is non-specific. Jaffe reagent can actually measure hemoglobin, uric acid, bilirubin, and if these are measured, they will all be reported as creatinine. Take note. So therefore, better add Lloyd's reagent. When you add Lloyd's reagent to Jaffe reagent, Lloyd's reagent is the Fuller's Earth reagent. Oh, the Lloyd's reagent removes the creatinine-like analytes. What are the creatinine-like analytes? Bilirubin, hemoglobin, and even uric acid. That's why we call the Lloyd's method the true measure of creatinine. Lloyd's method means the Jaffe reagent plus Lloyd's reagent. Okay? Kinetic Jaffe method. Ay, ito dapat ang na-perform mo kung nagkaroon ka ng face-to-face lab activities sa clinical chemistry 1. What is that? Kinetic Jaffe. It requires an automated equipment for precision. Siyempre sasabihin mo, ma'am, wala naman po kaming automated equipment. Ma'am, spectrophotometer lang kami sa school. O, edi doon ka sa Jaffe. Doon spectrophotometer lang. Pero kung yung school mo ay may equipment, may machine, kinetic Jaffe ang popular talaga. Ano nakalagay dito, guys, sa tatandaan mo? Naku, the concentrate, the absorbance is measured between 2 points. Ibig sabihin, there are 2 absorbance readings in kinetic Jaffe method. There are 2 absorbance readings. What else? And positive kinetic Jaffe method is also creates Janowski-like reaction. So, ayan ha. Kasi, syempre, sasabayan natin yung ano natin eh, yung ating board exam. At saka, syempre, we have a new set of examiners, okay? Baka mamaya itanong sa atin yan, Janowski reaction. Mom, ano yung Janowski reaction na yan? That is the other name for Jaffe reaction. Nako. Yung mga may book dyan, nandiyan na si Jaffe sa libro mo. That is the other name for Jaffe reaction. Si Janowski-like reaction, nasa book mo na rin yan, guys. Wala ka nang kukopyahin pa dyan. It's there already. Okay? Under kinetic Jaffe. Bakit mo sa amin na-emphasize siya? Baka mamaya hindi Jaffe reaction ang itanong sa'yo. Ang nakalagay sa choices, Janowski reaction. That is also Jaffe. Ano ibig sabihin ng Janowski-like reaction? The reaction of creatinine in the specimen, whether serum or urine, plus the alkaline peak rate creates red, orange, tautomere, T-A-U, T-O, tautomere, T-A-U-T-O-M-E-R, tautomere, T-A-U-T-O-M-E-R. Yung ibig sabihin ng tautomere. Okay? Ibig sabihin, reddish ang color ng end product, reddish. What is next? And enzymatic method. So currently, that is the routine, the enzymatic method. Okay, that is the routine method. Using the reagent creatine aminohydrolase, also known as using the creatinine aminohydrolase, also known as the creatinine iminohydrolase. Guys, pareho lang yung aminohydrolase at saka iminohydrolase. Same yan. Other name niya yung iminohydrolase. Baka kasi sa board exam, Mom, bakit nakalagay po doon aminohydrolase, yung naral namin, pero ang lumabas sa board, imino. Ay, that is other name. Okay? Other name lang yan, children. And what is the reference method? IDMS. That is the reference method for creatinine. Actually, yung IDMS na hindi pa nga masyadong 100% yung reference method yan, but that is considered. Okay? So, Ma'am, ano po ang routine method currently? What is the routine method? Ay, syempre, si enzymatic. Ma'am, can we use kinetic Jaffe as a routine method? Yes, pwede mo rin siyang gamitin na routine, but most is enzymatic. Reference, that is very expensive. Uric acid, major end product of purine catabolism. Not only product of protein catabolism, but also of purine catabolism. And the synthesis of uric acid in the liver and in the intestine requires the presence of xanthine oxidase. Take note, it requires the presence of xanthine oxidase. Huwag kalilimutan. Ano pa, children? Ops, magre-reflect ka. Ma'am, di ba si urea also produced in the liver? Correct. Ma'am, si uric acid also produced in the liver? Correct. And the creatinine in the skeletal muscles, majority. Small amount is secreted in the kidney, a small amount lang. But that is totally excreted. So ano ma-realize mo? The tests for RBF are not actually produced in the kidneys, but they are waste products coming from different organs and tissues. 95% of uric acid exists as what? Monosodium urates. Sabi nga ng mga biochemists, dahil daw ang ating blood pH ay acidic, sabi ng mga biochemists yan. Dahil sa ang blood pH natin ay acidic, anong ibig sabihin doon? Nako, ang blood pH natin ay 7.4. No? It is not acidic. Hindi natin pwedeng tawagin sa uric acid na uric acid. It should be what? It should be monosodium urates. It means at blood pH 7.4. How do you call the blood uric acid? Monosodium urates. And reference value, this is for the males and the females. For males, it is a little bit higher. And how do we convert this to millimole per liter? Times 0.059. It is times 0.059. Okay, huwag kalimutan. Konting tiis na lang, RMT ka na, kaya-kaya mo yan. What else? And how about, well, masyadong common to mga causes na to. Gout, renal damage, Lesch-Nyhan syndrome, okay? Those are really causes of hyperuricemia. Kung meron ka na lang dyan medyo i-memorize, no, baka makalimutan natin, that is lymphoma and anemia. They also cause hyperuricemia. Methodologies, chemical method for measuring uric acid is PTA, phosphotungstic acid method. Naku, obsolete na rin niya. Ops, si Jaffe meron obsolete, wala akong sinabing obsolete si Jaffe, ha. Kinetic Jaffe is still used in the academic laboratories like in our medtech schools, ha. Kinetic Jaffe meron din. Eto, we don't use phosphotungstic acid anymore. Tayo po ay uricase. This is the enzymatic method and we're using uricase. That is the current routine method globally. Reference method is also IDMS. So ano na-realize mo? Under tests for renal blood flow, these are the routine kidney function tests. Urea, creatinine, and uric acid. The routine kidney function test, do not forget that. Meron ka pang na-realize, they all use enzymatic methods as routine method currently, globally. And they share the same reference method, which is IDMS. Next. End product of phosphotungstic acid and uricase, both allantoin. Take note, ha? The end product of phosphotungstic acid and uricase, both allantoin. What else? How about disease correlations? Okay, in your book, you have their disease correlations. Let's start with azotemia. Azotemia is elevated concentrations of nitrogenous compounds in plasma, specifically urea. So, tandaan children, if urea is increased in plasma, and together with other NPNs, how do we call that? Azotemia. And primarily, which nitrogenous compound is taken up, always elevated and consistently elevated in azotemia, that is urea. What is prerenal azotemia? Ay, syempre, obviously, the kidney is functioning well. Bakit tinawag na azotemia? Because the main cause of prerenal azotemia is dehydration, severe dehydration. O anong mangyayari kung may severe dehydration ng isang tao? Kuhanan mo ng blood, i-measure mo yung urea. Huwag ka masu-surprise, ha? It is increased. Why? Because urea is one of the major solutes in plasma. So, pag kulang ang water mo, talaga namang all the major solutes in plasma, not only urea, will have increased concentration. So, ano nakalagay? Will have increased concentrations. So, ano nakalagay dito, children? Elevated BUN in prerenal azotemia. How about serum creatinine? Normal. How about GFR? That is actually decreased. So in prerenal azotemia, remember, elevated BUN, normal serum creatinine, decreased GFR. Ma'am, bakit decreased GFR? Children, pag naiihi ba tayo, pag nauuhaw tayo, pag dehydrated ba tayo, naiihi tayo? Naku, hindi. Na-experience mo yan? Oo nga ba, pag dehydrated ako, ako naiihi ba? O subukan mo kuhanan kita ng blood. Ay, elevated ang BUN. Ay, syempre, kasi na-concentrate siya sa blood. Do not forget that, because that is the most abundant NPN. Another cause of prerenal azotemia, congestive heart failure. Next, how about renal azotemia? Masyado nang obvious si renal azotemia. This is the true renal disease. Renal azotemia, do not forget, is the true renal disease. Why? Because this is damage within the nephrons. Do not forget that. This is actually damage within the nephrons. And Ops, what are the cases under renal azotemia? Acute nephritis and chronic nephritis. In other words, there is kidney failure in renal azotemia. Okay, there is acute. This renal azotemia is seen in acute nephritis and also in chronic nephritis. So, ano pang isa? Also, another case under renal azotemia is acute glomerulonephritis or AGN. Acute glomerulonephritis or AGN. Next, kuhanan natin ng blood sample. Yung mga pasyente nating may acute nephritis, AGN, kuhanan natin ng blood. Anong result ng BUN, serum creatinine, and serum uric acid? All markedly increased. Next, and there is electrolyte imbalance in renal azotemia. Ma, bakit may electrolyte imbalance? Children, baka makalimutan mo yung first page ng kidney function test chapter, ha? Baka makalimutan mo, may nakasulat dyan ng kidney function test. One of the important functions of the kidneys is the balance of electrolytes. In fact, what is the only organ only organ in your blood and in your body and in my body responsible for electrohomeostasis? My goodness gracious. The only organ responsible for electrohomeostasis or electrolyte balance, that is kidneys. Take note. Ma'am, paano ba binabalance ni kidneys yung electrolytes? Ay, syempre, dalawa lang kaya niyang gawin. Whether to reabsorb or to excrete. Kung kulang yung ions, dapat yan inire-reabsorb. Pag sobra-sobra naman sa body, dapat naman siyang ini-excrete. Okay, remember that, people. So, ang tanong, ma'am, are there influencers for kidneys that will affect the reabsorption and excretion of electrolytes? Guys, ito katatapos lang ng MTAP mo tsaka seminar mo exam, ha? I will ask you, what is that only, hindi naman only, what is the major electro-regulating hormone? Nako. What is that major electro-regulating hormone responsible for the balance of electrolytes, specifically the major ions? Excellent, Richmond Luis Estolas. What is that hormone? Aldosterone. And Oriza Antonio and Judith Bautista answered aldosterone. Oh my goodness gracious, great balls of fire. Uulitin ko. Aldosterone is known as the major electro-regulating hormone. Take note. Hindi ko sinabing only, ha? Let us be careful with the question. I didn't say the only electro-regulating hormone. Wala ko sinabing only. Ang sinabi ko, major electro-regulating hormone. It means aldosterone is not the only hormone responsible for the balance of electrolytes, but it is the major. Why? Because it regulates the major ions such as sodium, potassium, chloride, bicarbonate, and hydrogen ions. Take note. So, ang tanong, ma'am, di ba si patient may renal azotemia? So, what happened to the concentrations of electrolytes? Oh, one electrolyte should be monitored. Guys, what is that electrolyte? That should be carefully monitored. That should be closely monitored. If that patient is under the category of renal azotemia, hindi ko sasabihin ang answer. 5 seconds. Kung board exam ngayon, guys, what is our answer? What is that hormone? Justin and Amar. Excellent. And Inyon. And also Judith. And also Nestor and Raymark and Andami and everybody. What is the answer? Potassium. Excellent, guys. That is definitely potassium. Tony Cruz, Justin Ann Amar, Richmond Luis, and the four ladies. Hello, Cabubas, Castillo de la Cruz, Paula Martinez, Law Office. Joke lang. And also Christine Calbrinas. Everybody answered. Raymark Magleo, Potassium. Excellent. Children. Siyempre, bakit si potassium, hindi si sodium, si calcium, si... Well, ano ba ang favorite area? Ano ba ang favorite electrolyte ang ine-excrete ni kidneys? Paborito niya excrete yan. Dapat bawasan sa blood yan, otherwise the heart will be impaired. That is none other than potassium. So in renal azotemia, there is hyperkalemia. Remember that. In renal azotemia, there is hyperkalemia. And hyperkalemia is dangerous. That will cause actually dysfunction to one organ. What is that organ that will be compromised in the presence of hyperkalemia? What is that first organ that will be compromised, guys, in the presence of hyperkalemia? What is that organ? The heart. Tama, lahat ng sumagot ng heart. Yes, because potassium is the most important cardiac ion. Remember that. Because potassium is the most important cardiac ion. Do not forget that, people. If you have hyperkalemia, no, wag naman, Lord, yung cardiac muscle mo nagko-contract, it will just stop. Pag nag-hypokalemia naman tayo, yung cardiac muscle natin nagko-contract normally, nagkakaroon ng arrhythmia. So what happened? These are both dangerous situations. Okay? So there is elevated NPNs, there is hyperkalemia in renal azotemia or true renal disease. How about post-renal azotemia? Post-renal is actually due to nephrolithiasis or presence of kidney stones, katulad nitong nasa picture na yan. So what happened in post-renal azotemia? Ay, obviously, pag meron kang stone along the ureter, that is definitely decreased GFR. Kasi doon makita mo agad may stone eh. So what happened to the most abundant NPN? The more that it is, it will be reabsorbed. Take note, and that is elevated BUN. How about creatinine, serum creatinine in the presence of post-renal azotemia? It depends. Because remember that creatinine is normally excreted. It is not reabsorbed, normally excreted. Unlike urea, there is 20 to 40% reabsorption normally. Si creatinine, 100% excreted. So what is the expected concentration of plasma creatinine in post-renal azotemia? It depends on the presence of the stones. If it is on the upper kidney and not actually obstructing the flow of urine, yung creatinine mo normal pa rin. Pero if the stone, guys, cause obstruction, that is the time that the creatinine will be slightly increased. So how will you summarize the three types of azotemia? In the three types of azotemia, BUN is consistently increased. Second, serum creatinine is markedly increased only in renal azotemia because in prerenal, the serum creatinine is normal. In postrenal, normal or slight increase. And another thing that is consistent in azotemia is the GFR because plasma and clearance is inversely proportional. If the concentration of NPNs in plasma, just like BUN, just like creatinine, just like uric acid, they are increased. What happened, children? If they are increased in plasma, what happened, guys? Well, it is definitely decreased urine output. That's why it is decreased GFR. How about uremia? This is severe form of azotemia. Take note, a severe form of azotemia. Bakit? Kasi hindi lang elevated NPN, hindi lang hyperkalemia, meron pang acidosis. Metabolic acidosis. Bakit ng pH imbalance, ma'am? Well, tingnan mo na naman yung first page ng kidney function test. Because One of the important functions, patawad guys, hindi ko masagot ang tawag na ito. Okay. Sorry, nako. Mukhang may emergency meeting kami. Patay kang bata. Wait lang, children.